To make the fish feeder, we're going to need some sort of motor to turn a wheel that then feeds the fish by dropping food into the fish tank. What I'm chosen to use is a stepper motor. This is a fairly typical stepper motor. Try to get the angle right for you here and focus on that so you can see that it says 28BYJ48. It's a 5-volt DC motor. They're fairly standard. There's not very much to them. I bought this one quite cheaply, and on the other end of this cable, you can't see the whole cable here, on the other end of this is a little circuit board which is upside down for you. You can see the quality of what we're buying here, the little circle not being displayed there in full. Pins N1 through N4 are what we're going to drive, these 4 pins here. We'll drive those with the microcontroller, and there's a little chip on here which converts this into, or sends the pulse. You can see down the bottom here there's 5 volt, which is over these 2 pins. There's a jumper over the 2 pins next to it, and what that jumper does is feeds the same voltage that's coming through these pins through these resistors to these 4 LEDs. And the result of that is that the LEDs will light up when we apply power to each pin. So you put power on pin 1 and the LED number 1 comes on. It's useful for debugging and understanding what's going on, seeing just how fast you're actually driving this thing and how slowly the motor will turn. And if you don't want those lights flashing when you're busy doing it, you just take this jumper off and leave those 2 wires exposed. Put it back on and your 4 LEDs flash away. So that's it. That's what we're going to use in terms of driving a motor. The shaft has got a small flat on each side, and we'll use that as the driving force. It's a pretty strong motor. You can't actually turn it with your hand, so it's quite strong. So I'm not even sure we're going to need to put any gears or anything on this. So that's the motor side of it, but in order to control that motor we're going to need some sort of program, and the program is going to run on a chip. This particular chip here, which is upside down for you. Don't know if I can get to see it on here or not. There we can. It's an M430 G2. Well, this one's a 2452, but what I'm actually using is a 2553, which is the one that comes with the LaunchPad. Now, obviously, it's very difficult to program this thing just as it is, because connecting it up to your computer is not that easy. So what you tend to buy is something like this, which is it's an MSP430, that's 430 LaunchPad. You can see down the bottom here, Texas Instruments LaunchPad. Focus. He's not focusing. He doesn't like being so close, I guess. I don't know what it is. So you can see how it's a Texas Instruments LaunchPad. The LaunchPad has the chip, this little chip here, placed into a socket. And what you can do is you can remove this chip and put it into a breadboard, for example, if you wanted to. Now, on this model of the MSP430 LaunchPad, you can see over here on the left, resistor 34 is missing. And as a result, because resistor 34 is missing, we're going to have to change some of the code in terms of this push button here down the bottom. They have these built-in little push buttons. This is a reset button over here, and this is the just a push button that you can use to drive things to. So what I'm doing with mine is we'll use that to enter a debug mode, which means we'll run the program faster because we don't want to be waiting 24 hours to feed the fish. On my particular one, I've replaced the male headers, because what it typically has is pins along the side here that just jut out, which wasn't that easy for me to use in terms of connecting it up with the breadboard. So in order to stick a cable from the MSP430 into the breadboard, I decided to switch these over for female headers. You'll probably find a video on YouTube about that if you're interested. You basically remove the plastic and then you desolder each one, and then you put these in and solder them on. So that's the MSP430, and you can buy replacement chips quite cheaply. This particular board you can buy for less than £10 in the UK. A small board like this is also fairly cheap, a couple of quid, I can't remember how much. And we'll use this. I'm going to be buying a power unit, which is £1, and it plugs right into the top of this and provides 3.3 volts on one rail and 5 volts on the other. And the reason I want that is because this thing wants 5 volts, that thing wants 3.3 volts. So I need the two different voltages. Now, when I actually write the program, you'll notice that I use pins, what are they? When I write the program, you'll notice that I use pin 2.2, I think 2.1, 2.0 and 1.5, which are basically the four last pins on this side. And the reason I do that is because I can take my motor and simply put those into those 4 pins directly, like that, and slide it in. Now all 4 pins are directly connected, at least for prototyping and testing. That works just fine. There's absolutely no problem with that. It's a little bit awkward because the reset button, or the pin 2, is underneath there, which is difficult to get to. But otherwise, yeah, there's no problem with that.